All right, we're going to continue on. Aircraft fuel systems. Moving on, it's pretty much the same as fuel quantity indicating systems, but I've divided it into two. And the second one, fuel measurement, which basically will allow me to talk a little bit about fuel flow in addition to fuel quantity. So let's see what we've got going here. Everything looks good. Yes. All right. Fuel mass is referred to in a few of these questions. You may have seen it already. So let's talk about that for a minute. The density of jet fuel varies more widely than the density of avgas with variations of temperature. However, most of the charts that I have almost looks like avgas and jet fuel almost follow the same type of variations for temperature. So I'm not exactly sure. I guess we're just going to take it as doctrine that jet fuel or jet A does the density does vary with temperature. That becomes important when fueling the large jet transport aircraft. Basically, the basic rule is that the higher the temperature, the more the fuel expands. Colder temperatures contract the fuel volume. So, hotter fuel basically takes up more room in the fuel cell than colder fuel, which contracts. The question is, when fuel quantity is measured in pounds instead of gallons, the measurement will be more accurate because fuel volume, A, varies with temperature change, B, increases when temperature decreases, or C, varies with changes in atmospheric pressure. Well, we've been talking about temperature, so I wouldn't jump into any pressure situation. But if you're just looking at the problem, you may not realize that we're approaching it from that angle. So basically, when they're talking about fuel volume and the pounds and the gallons, they're talking about the temperature. So A appears to be correct right by itself. Fuel volume does vary with temperature change. Let's take a little closer look at number two. Does fuel volume increase when the temperature decreases? Well, when it gets colder, we saw that it contracts a little bit more. So actually, fuel volume decreases when temperature decreases. So A appears to be the correct answer. The engine uses the fuel on the basis of its weight, and the volume in the fuel in the tanks changes as the temperature of the fuel changes. There's an electronic measure, a nice feature of the capacitor type or the electronic fuel quantity indicating system is that it does not measure fuel quantity by volume, but rather by weight. And you can see that right in the indicators. It's in pounds per 1,000 pounds. This one here is fuel flow, pounds per hour. So we've got fuel quantity and fuel flow. And they measure by pounds and not by gallons. Why is the capacitance fuel quantity indicating system more accurate in measuring fuel level than a mechanical type? Why is it more accurate? Well, let's see what the options are. A, only one probe and one indicator are necessary for multiple tank configurations. Well, that is definitely not true. The capacitance type will use many indicators, multiple in one tank even. So if there's multiple tanks, there'll be even more indicators. B, it measures in gallons and converts to pounds. Well, the capacitance doesn't do any converting. It basically measures in pounds. It measures the mass, the thickness of the fuel that is acting as the dielectric. So opposite of what that one's saying. So C, it measures by weight instead of volume. So that is the only one that's actually true by itself. Whether it actually lines up with the accuracy portion of the problem probably is irrelevant at this point, I would say, because it is the only answer that is true. It's going to have to be the correct answer, and of course it is. Capacitance type fuel quantity indicating system measures fuel in what? I guess if they're going to ask you once, you're probably not going to get all these questions, but you might get one or two of them. So be aware the capacitance measures in its mass or its weight. Weight is in pounds, and as opposed to gallons. So what about this pounds per hour? It's a fuel quantity, so the only thing it's going to measure is how many pounds of fuel that you have. I know there's a lot of questions on the capacitance electronic type, and they all follow very similar formats. So if you know the concept, which isn't that difficult, you may get multiple correct answers. Even an oral question. Why are electronic capacitance type fuel quantity indicating systems more accurate than other types? Well, if you've been following along, you're going to basically recite that they measure the fuel in terms of pounds as opposed to volume, which is more pertinent to the turbine type engines. Strike that last part. I think the first part's plenty. Yeah, they measure the mass of the fuel instead of the volume. The mass or the weight or the pounds. Mass is a good word to use when you're talking about what the capacitance type measures. A little review on the electrical type. We can see the float. Basically, it is attached here to an arm which has some electric wires going from it. I would imagine the resistive element is in the casing here. Consists of a indicator mounted on the instrument panel. I guess that would be not shown here. A float operated transmitter, that is shown. As the fuel level changes, the transmitter sends an electric signal to the indicator which shows the changing fuel level. With this system, the indicator can be at any distance from the tank, and the fuel levels in more than one tank can be read on a single indicator. All right, let's think about that for a second. The indicator can be any distance from the tank. So here we don't see the indicator, but we see the wires. So basically you attach, or at least the the posts at the top. You attach your wires and take it any distance that you want into the flight deck on the instrument panel. So that part is true. It can be any distance from the tank. And the fuel levels in more than one tank can be read on a single indicator. There's a variety. And yes, sometimes it's on a single indicator with actually two needles. You can certainly run these so that onto a dual type indicator. Talk about it enough. FQIS, fuel quantity indicating system. The electrical part, again, we got the float and the resistive element. It's usually a ratiometer. Nothing too exciting on here. Here's a closer look at the ratiometer circuit. There's the variable resistor on one side and a compensating resistor on the other side. And running power through that from the plus through to the both of the grounds, you're going to get a stronger signal depending on what resistance is in the respective branches. Which I guess the instructor could talk a little bit longer about this, but I think you can kind of see how it's working. Picture putting power through where the plus goes. It goes to ground on one direction, ground to the other. It looks like there's equal number of turns in the respective coils, so the respective magnetic strength should be the same up to this point. Where it's actually going to change is where there's a less of a resistance here, because let's say the tank is half full, so the wiper on the float is pointing to this part of the resistor, which is less resistance than the part on the compensating resistor here. So the electricity tends to follow the path of least resistance, which will actually show it. It's calibrated to the corresponding fuel quantity. So if it's half, it's calibrated so that when the resistor is at this point, the indicator points straight up and down. An electrical type fuel quantity indicating system consists of an indicator in the cockpit and a float operated transmitter installed in the tank. Sounds good so far. B, float resting on the surface of the tank. No, it's actually on the surface of the fuel. Or C, float operated receiver installed in the tank. Okay, they're using the word receiver in the tank. So the receiver would be in the cockpit, then the indicator, and the transmitter would be installed in the tank. So the only one that's true is A. What is the purpose of a float-operated transmitter installed in a fuel tank? See, there it is. A transmitter is installed in the fuel tank. What is its purpose? A, it sends an electric signal to the fuel quantity indicator. Kinda. B, it senses the total amount of fuel density. No, that's going to be the capacitance type. A float has no it floats regardless of the density of the fuel. So its indicator is going to be the same regardless of the density. Or C, it senses the dielectric qualities of the fuel and air in the tank. Again, that's a description of what the capacitance type, which does not have a float. It does not have any moving parts in the tank. So again, the only true answer is A. A fuel totalizer, it's a summation unit, and it's part of a capacitance type fuel quantity indicating system. It's used to add the tank quantities from all the indicators and give the pilot an indication of the total number of pounds of fuel remaining on one indicator called the totalizer. So what do we have here? It looks like it's 3 tanks. There's 28 quantity. We're talking about kilograms. It's not exactly pounds, but it is a weight. So 28 keys in the right wing, 4 keys in the middle, usually the fuselage tank, for a total rather than adding them up or pulling out your calculator. It basically adds up to 3. Not exactly the same because I see 0.2, 0.6, 0.2, which should be a 0.0. So let's follow up on it and see what the difference is. 28 and 28 is 56, plus 4 is 60, plus the 1. So actually the fuel totalizer should total 61.0. Maybe it's rounding up. Total aircraft fuel quantity can be used by the crew and by flight management computers for calculating the optimum airspeed and the engine performance limits for climb, cruise, descent, etc. There must be a question about a fuel totalizer. There is. A fuel totalizer is a component which indicates the A, total amount of fuel being consumed by all engines, not consumed. B, the amount of fuel in any given tank. Well, that's part of it. But the C, the amount of fuel in all tanks, the total of all tanks. So it's C, the totalizer. A digital fuel totalizer automatically indicates the amount of fuel used, fuel remaining, current rate of consumption, and fuel. It gives you a lot of information. So it tells you how much fuel you've used, how much you have remaining, what your current rate of consumption is, and fuel. A, weight aboard at takeoff. Well, that'd be like a historical record. So no, it gives you live records, and aboard at takeoff, that would almost be noted in the records. B, the fuel remaining at the 45-minute IFR fuel reserve. That's instrument flight rules. I didn't show a regulation that requires that. Let's see what the last one says. Fuel remaining flight time at the current power setting. All right, so basically fuel remaining has already been stated. So fuel remaining and flight time at the current power setting. I can accept that, and I'm not sure if there is a rule, a special rule that requires totalizers to show a 45-minute IFR fuel reserve. I highly doubt it, so I'm going to say C. Oh, way off. All right, I'm not helping you much, am I? Okay. A digital fuel totalizer automatically indicates the amount of fuel used. Well, I suppose in order to make the other calculations, it would have to indicate how much fuel we started off with. All right, my bad. And all the tank, and it gives the pilot an indication of total. I don't know. I'm going to presume that's the correct answer. The explanation doesn't throw it off. Almost should look at this one a little closer to verify. 8746-2. Let me take you for a little trip as I look that up. All right, let's see. 8746-2. -2. Here it is right here. And what is the correct answer down here? It is A. Weight aboard at takeoff. All right, I guess I accept that. I didn't like the fact because it said it indicates 1, the amount of fuel used, 2, fuel remaining, and then all of a sudden 4 is going to be in fuel remaining with another comma. So I didn't like it for that reason. But for some reason I discounted A right away. All right. I hope I didn't throw you off on that one. So, an important advantage of the electrical and the electronic type fuel quantity indicating systems are that the fuel quantity indicator can be located any distance from the tank because they use an electrical wire to carry their information. And I tried to show that with the blue line. The indicator compared to the two float sending units in 2 different tanks. Also, the fuel levels of several tanks can be read on one indicator. We already looked at that a little closer. And here's the question. One advantage of electrical and electronic fuel quantity indicating systems is that, well, without even reading the options, it's going to be that the indicator can be any distance from the tank sending units, or that both, one indicator can show the readings from more than one tank. So which one is that? That would be C. Several fuel tank levels can be read on one indicator. Similar to the question we saw before, the indicators are calibrated in gallons? No. The electrical may be, but the electronic is not. Only one transmitter or one indicator is needed, irregardless of the number of tanks. No, you need at least one transmitter in each tank. So several fuel tanks can be read on one indicator. But here's the other advantage. One advantage of electrical and electronic fuel quantity indicating systems is that the indicator A can be located any distance from the tanks. So basically, your two options or your two advantages are going to appear in two different questions. Has no movable devices. That might be a little tricky because it was a correct answer in a different question. But electrical does have movable devices. It has at least the wiper is movable on the resistance. And C always measures volume instead of mass, kind of the opposite. We know electronic measures mass, so you could get to the right answer by eliminating the two incorrects. So, A. All right, sorry, I forgot to go back to my slideshow. Dripstick, this is a large transport category aircraft will normally have a way for ground personnel to actually physically look at how much fuel is in the tank. And one of the more irritating methods of doing that is a drip stick where the fuel actually drips out. You basically pull it down until fuel drips on your hand. That's note the number of inches read on the outside and then use a conversion table. Yes, that's always a nice little project to give to students in general. You can read about the dripstick here. It's a hollow tube. They call that like a bayonet type gauge. Unlock it, slowly pull it down until you feel the fuel. And they call that a dripstick. A sight gauge. It doesn't necessarily have to be a tube on the side of the fuel tank. It could actually be something that you look into. You actually look in the bottom, and there's a quartz tip, which will give you a reading. I'm not that familiar with this, with the sight gauge. It works as the same basic principle as a drip stick, but it doesn't have the fuel dripping from it. So far I like it, especially if you're going to look into the window with your eye. You don't want fuel dripping, so make sure you got the right one before you start looking up the drip stick. So basically you unlock it, pull it down while watching the rod through the sight window. I guess there's an acrylic rod there. When the quartz tip is above the fuel, it reflects light back down the rod. As the rod is pulled and the tip enters the fuel, the amount of reflected light decreases. So, kind of interesting. I don't know if I've actually used one or seen one. I may have and just don't vividly recall. Question about a drip gauge. A drip gauge may be used to measure what? A, the amount of fuel in the tank. B, the system leakage with the system shut down, so you can measure the drips. Or C, the fuel pump diaphragm leakage. Again, they're talking about something that might be drips, but it's actually something that's used to measure the amount of fuel in the tank. It doesn't actually measure drips. What are drip gauges and sight gauges? They're basically fuel quantity indicators that can be used by ground personnel on the ground. They're usually bayonet style on the bottom of the wings, and it's a way for ground personnel to actually make a confirmation of the amount of fuel in the tanks to make sure it corresponds with what the indicators in the cockpit are showing. Underwing bayonet type fuel gauges. All right. I guess I got a little more verbose, but I think I hit it all. What's the purpose of a drip gauge in the fuel tank of a large aircraft? Same answer. How are we doing for time? All right, we can cover a few more of these issues. I don't think there's going to be too much. I think there's one question and a few extra slides. A method of physically checking the level of fuel in the tanks of a jet transport aircraft. So, physically checking it. Do you actually open up the spout and look in it with a flashlight? It's probably one of the options. No, you don't. Do you use a drip gauge? So far, yes, if one is available. B, by visually inspecting the fuel level from the above wing fuel filler openings. Well, jet transport aircraft normally isn't always doesn't have a filler opening always on the above the wing. A lot of times it's below the wing, a pressure fueling. And you wouldn't do it that way anyway. Or C, a sight gauge on the side of the tank. Well, it'd be nice if there was one, but this is a jet transport aircraft. You know you're not going to actually see a sight gauge on the side of the tank. Now, it might be one of those sight gauges that actually work from under a wing, but this one says the side of the tank, so that one is not going to work. So a drip gauge is the only one that continues to work. The little fuel drip stick, we're kind of showing a couple. They're also called measuring sticks. Apparently they're on all airplanes under Part 25 and some corporate class airplanes. Their purpose is to allow the ground crew to physically check the fuel level, so they're actually required. And that's also when electricity is not available. Most installations consist of several drip tubes in each wing. As an example, a Boeing 727 has 6 in each wing. So we do have a 727 out there, so go take a peek and get a little fuel. Pull it down until you get the fuel, and we'll count that as a project. So look for the project in another section of D2L. One type of on-the-ground fuel indicating system utilizes magnets that attract to each other when the level of the measuring stick meets the level of the fuel tank float. The portion of the stick pulled out of the bottom of the wing shows the fuel quantity. The magnets basically line up. There's one up here and one over here. So when you start pulling it down, the magnets will line up and almost lock a little bit. And so you take your measurement, and that should be accurate. Fuel sticks are located under the wings of most transport-size aircraft and on the lower fuselage of some large air carrier aircraft that use auxiliary fuel tanks. Here's the float type. You're not going to see those too often anymore. But in this case, the fuel tank is going to be forward of the firewall, which I don't believe is going to be permitted anyway. I can't tell. Is there a propeller on this, or maybe the propellers, and maybe it's a twin engine with propellers on both wings, with a fuel tank in the nose, with a little floating sight gauge that floats up and down depending on how much fuel is in the tank. This one's on a Piper Cub. If you want to look into that a little closer. Interesting. We already saw the fuel indicating system with the float, where in this case the float is going to be a direct mechanical attachment with no wires. So as the float rises, it's going to turn the gear, which turns the pinion gear, which is attached to a shaft that together with a magnet will actually turn the indicator. All right, that looks like all we need. All right, looks like our time's about right, so I appreciate everybody's attendance. And a few more and we can wrap up fuel systems. All right, I'll see you then.